Find the answers to questions you may or may not have asked yourself here at Kaleidoscience, Conversations on Cognitive Science.
I think pain is an experience almost everybody has had at some point in their life. And while it is often painful in the first moment, sometimes we can get used to pain over time. Today we're talking with Maite van der Miesen from the University of Maastricht, who is a PhD student there and does her research in pain and habituation. Welcome.
Thank you. Hello.
And as always, at the beginning, we play our short get-to-know game. For this, I will give you 5 sentences and you can finish them. Oh, we ask you to finish them spontaneously. The first sentence is, as a kid, I always wanted to be.
I wanted to be an illustrator when I was a kid. I think this was when I was very young, like 5, 6, 7.
Do you have something specific in mind you wanted to illustrate, or just illustrate whatever?
Yeah, I think I also wrote small stories and then illustrate these.
I used to do the same.
At some point it stopped though, and then I didn't want to be anything until I decided what to study, I think.
The second sentence is, if I was an emoji, I would be.
I would be, I think, the grimacing emoji.
Which grimacing one?
That shows the teeth.
So the grinning one, like that's a
yeah, but then that was not to make a pun already, but the painful one where it's kind of awkward and I think you can use it in so many situations and to add a bit of sarcasm and stuff.
True. The third sentence is, my favorite thing to do on a day off is.
Oh, that's a difficult one. Many things I like to do. I really like hiking or playing the harp. I do often in my free time, or playing board games with friends.
Sounds all really lovely. I'm always impressed when people play the harp because I think it's such an impressive instrument. It's like so huge and just sounds super soft, but still strong. I just really like the sound of it.
It's not as difficult as people think, so you can always try. I like that people always think, right, that it's very soft and gentle music, but you can actually play a lot of different types and jazz music and more rock as well. So you can get a lot of different sounds out of it.
I sometimes play the ukulele, and I at some point started to play the intro of Nothing Else Matters from Metallica, which works quite well on the ukulele because the ukulele is super high.
Yeah.
So that works quite well. I was just thinking, like, which rocky metal songs could sound well on a harpy?
And I don't know if you know the song Karma Police. Is it by Radiohead? Or Karma?
Which one?
It's a song by Radiohead. I think it's Karma.
Possibly. I'm really bad with song names, I have to admit. Like, I have to listen to it and then I could tell you. But I'm going to listen to it and tell you if I know it. Okay, next sentence. Right now, I'm most fascinated by.
I'm not sure. Oh, I think, some time ago I discovered a new instrument. I think that's something that I often look up. It's the duduk. I don't know if you've heard of it.
No.
It's a flute from Armenia. And I actually looked into whether I could learn it, but it seems to be super hard. So I think that would be something I'm fascinated by.
And how far, like, for me, it's somewhat difficult to imagine it difficult to play flute. So is it?
Yeah, I think the breathing technique to get like enough airflow through it to get the right sound.
Okay.
Which is apparently more difficult than with a regular flute.
Interesting.
maybe after I get my PhD, I will get into it.
And our last sentence is, I know it's time to call it a day when.
I think I'm someone with a lot of structure and rhythm. So I would say when I look at the clock and it's 5 p.m., it's time to go home. And I
That
think the
sounds
same
so healthy.
for going to bed. Yeah.
That sounds really healthy. I think our most common answer is, I know it's time to call it a day when I can't focus and when I just start falling asleep in front of my laptop. And I'm always like, I feel you, but that's just not healthy.
No, the 5 or 6 p.m. is it for me.
Sophie already mentioned that you're currently doing your PhD at the University of Maastricht. Could you maybe tell us where you started, where you did your bachelor's, what you did in your master's, and how you ended up doing your PhD in Maastricht now?
Yeah, so I started my bachelor in Amsterdam. I studied psychobiology, so really the combination, because I was really interested in both aspects. So I thought learning about both biological process and psychological was great. And then after that, I continued master cognitive neuroscience in Amsterdam as well. And then during the research master, we had to write a literature review. And I was looking for a topic in which I could again combine these two aspects. On like for some processes, like visual attention, it's more studied, on a behavioral level. And I was also already, since I did a bachelor internship focusing on MRI, was interested in using MRI as a method. So I was looking for a topic that I could write on that had all these aspects. And then I don't know how it started, but I somehow thought about, pain has this aspect. So it has a very clear biological aspect, a very clear psychological aspect. And there is a lot of fMRI or MRI research going on. And then I Googled researchers doing this, and I found a professor in the US, and I contacted him to write my literature review with him. And that was so interesting that I thought, okay, I want to continue research about pain. And then I ended up in Maastricht, where they had this position available.
That sounds like a quite surprisingly straightforward path, actually.
I
Like it
think that
doesn't.
in hindsight, yes. But on the way, I was searching for, what is
Okay.
interesting and who shall I email? And then, people not emailing back, and then,
Yeah.
But in the end, it was like a good timing also with the position becoming available.
You just mentioned MRI and fMRI. Could you maybe just in some words say what the difference between those two is?
Yeah, so the MRI scanner itself is this a magnetic field where you can basically make images of your brain, and you can make different type of images. So you can scan the anatomy, so where you see all the different structures in your brain. So this is what we say with MRI. But you can also make functional images, and that is fMRI, where you can look at the function of the brain areas. And that's, of course, really interesting in the context of pain. I mean, with many things, this is interesting to look at, but then you can look at how brain areas become active when you're in pain.
Yeah. Before we go deeper into that, can you maybe explain us what pain is in your words?
And pain is, I think, the most important aspect of that is that it's a very subjective experience, and that it's signaling actual or potential tissue damage to the body. There's, like I said before, a lot of things that influences. So there's a lot of psychological, but also social factors that can influence it, and that makes it, from the research I super interesting to study, but also from a practical side and more clinical side, really complex, because there's not one pathway or one cure. So that's, yeah, it's both fascinating and also really difficult, especially if you suffer from pain or chronic pain.
So, how do you do a pain experiment?
So in the labs we use, there are different ways to study pain. And there's, of course, animal models, but I study only in human participants. And there we have a few basically stimuli types, so different ways to administer pain. So we can use thermal stimuli, so heat or cold, or electrical stimuli, or pressure. And these all result in pain for the participant. Of course, this is different from what we experience when you hit your knee or you fall, but it's very difficult to actually get a similar experience in the lab with a controlled setting. So these are the ways that are most common in the lab.
And do you know of any advantages or disadvantages in some of these pain modalities?
So there's different receptors in your skin that give the signals basically to the spinal cord and the brain, and the different, like, heat and, for example, targets different receptors than the electrical pain, and that also makes it, yeah, that gives a different pain experience. And some of these, like the heat pain, we are more familiar with from our daily life than others. But often it's also very practical, like what is available at the university. So there's not really one that is more beneficial or better. It also depends on the type of research questions you have.
If you use a stimulus that, or what would be a stimulus you could use that is not that familiar? Just as an example, like would it be the pressure or?
I think also the electrical pain is, and pending, like people living in the country have maybe more experience with touching a wire. And then I think also the pressure pain is less common in your daily life.
If you are less familiar with the type of pain, could that also influence on how far you react sensitive to that? Because if I imagine that I don't know how bad something can be, I would always expect, if I'm told that can be painful, that it's more painful that it would actually feel when I would be used to that type of pain. So, like, is there a type of bias, or how do you
Yes, I
control for
think
that?
that's difficult. I think expectations play a huge role in pain in general. If you expect something to be very painful, it is often more painful than when you expect it to be not as painful. So your previous experience definitely play a role, but this is very hard to measure because a previous experience can result in that you are actually less afraid of the pain, but can also increase the expectation of the pain. So there's a lot of individual variability in this.
And especially when it comes to electroshocks, like, is it ethical to do that? And what is ethical and what isn't? Like, I assume you're not trying to grill people, but
Yeah,
like, what can you do and where's the limit?
yeah, there's a lot of ethical guidelines when it comes to pain research. It's definitely, like, important that you only use the strength of the stimulus that is necessary for your research, and you should never exceed the tolerance limit. Of course, the participant should give consent beforehand, and always should be able to stop at any moment in time. I think also the way there are a lot of guidelines about how to phrase the context of your research. Like you just mentioned electrical shocks. This is something that is not allowed for our research. So we can say electrical stimulus because already the word shock shows you that it is potentially harmful and painful. So there's a lot of things that you should consider when you design your experiment. And there's a lot of other biases present that are very difficult to control for. For example, like the context in which you are, like even the situation if you are in the lab or if you're in the MRI scanner can give very different pain responses. Also the person that investigates, so the researcher, if this is like a professor, it influences the responses of the participant versus if it's someone at an equal level. The gender can also influence both of the participant and the experimenter. And so there's a lot of factors to consider, but that are also sometimes difficult to control for. But as if you keep them as controlled as possible, then that's the way to go forward, I would say.
And you also work with habituation. Could you also explain a little bit what habituation is and how that is related to pain?
Yeah, so habituation to pain is basically when we're getting used to pain. And this sounds a bit counterintuitive because pain is there to signal a threat. But sometimes, or the idea is that in some cases, we don't need to be as focused on the pain, and it's actually beneficial to get used to it, to adapt to it, so that we can shift our attention to other things. And this is, for example, like also, it happens basically in every context, not just with pain, but also when there's, for example, an annoying sound at some point, you get used to it, so you habituate to it. And this, it has been studied like in a lot of domains and throughout the animal kingdom. So it's a very universal process. Actually, the first research description of it, this is, I think, quite a funny story, is from 1887. And it was described in a paper that was some observations on the mental powers of spiders. So this was not yet related to pain, but more the general aspect of habituation. And there they looked at spiders in their webs, and then they held like a tuning fork in front of it, and they picked it, and then the spider would get startled, so it would drop from the web, and then after some point it would climb back in the web, and then when they again hit the tuning fork, they saw that the spider would drop again, but it would be faster back to the web, and also less annoyed by it. And this is basically one of the first research descriptions of habituation. And this has then been expanded to a lot of other fields and domains, and in the end also for pain.
We've now heard a bit about habituation, but could also the opposite happen, that when you're always constantly getting a stimulus, might be something painful or whatever, that exactly the opposite happens? That means that you get more sensitive to it.
Yes, so this is the process that is called sensitization. And indeed, this is the opposite. So there you show an increased response to a stimulus. So in the case of pain, you report more pain over time, basically. And I think some interesting aspect also about habituation when it was first studied, like in the broader context, it was even seen as pathological at some point. And then the idea was that if you show a stable response, then that is good and healthy. But when your response diminishes, then that was actually seen as a bad sign. So I know that like in the First World War, they were screening for like prospective aviators to look at whether they actually showed some signs of habituation or not, to see whether they can participate in the war.
Interesting.
That changed a lot over
Yeah.
time, and
Like
more
now
research.
people don't think that habituation and less pain experiencing is something weird.
Yeah, now it's seen really as beneficial, and that you can focus your attention on something else.
Okay, let's go a little bit deeper into the topic of pain. What happens in the body and brain when we are in pain?
Um, this is a very general question. So a lot of things happen in the body and the brain. There's usually a division into peripheral processes. So on the location into your body where, for example, the pain is happening. So when you hit something, when you have pain in your hand, then there's a lot of local processes happening there. And that it's also signaling from there through the spinal cord and the brain. And also from the brain, there are signals back to the spinal cord. And all these together make you experience pain.
And when we habituate to pain over time, so when it's the same sensation, like I hit my knee twice, about roughly the same amount, but the second time, or maybe not the second, but maybe after multiple times, I feel it a little bit less. Um, what is the thing that changes?
So there's actually not that much known about the mechanism. Um, there are some ideas about um, yeah, plasticity of our neurons, so the cells that transmit the signal to the brain. But there's also ideas about influences from the brain, because your brain can also signal like, okay, this signal is not so important. We can adapt to it.
Okay, so when you do research on pain habituation in particular, um, how does an experiment look? Like when I come in as a participant to your experiment, how could an experiment potentially look, or what was I going to experience?
Yeah, there's, I think, basically two types of way to set up an experiment for measuring habituation. So you basically want to measure how someone is adjusting to the pain. And one way is that you give a participant a stimulus that is always the same. So if you use an electrical stimulus, then you use always the same amount of voltage or ampere and that you deliver to the participant. And then the participant can, for example, give pain ratings and then indicate the level of pain they experience with each stimulus. And then if you see it decreasing, so a decrease in their response, then this is an indication of habituation. Another way of researching this is that the participant also gives a rating for each stimulus, but instead of looking how the ratings change, you actually adapt the voltage so that the ratings are constant. And then you can see that this change in voltage, if you have to put it higher and higher, you also see that the participant adapts to the stimuli. But I think a lot of it is still unclear about how to actually measure habituation. So we adapt to it and your response decreases, but what does this actually mean? So it means a lower response, but it will be kind of like a statistical measure, even like what is lower, basically. And this is very difficult, especially like or already if you look at pain ratings, but even more when you look at neural measures. So if you look at fMRI and brain activity, how do you measure a decrease in activity? So there's still a lot of unclear about how we actually define this process, even though it's so common and universal.
So you work with the participants' ratings during the experiment, like when you adapt the stimulus or when you show them the same stimulus, but there's no like objective physical way which you can measure pain, right?
No, I think in itself, pain is very subjective. And especially when it comes to brain activity, there's a lot of controversy about if we just look at brain activity, can we even call it pain? Because we kind of need a verbal response from someone to confirm, okay, this is actually painful. And we can look at activities in areas that we know that are related to pain. But officially, you're not allowed to say someone is in pain without the person itself confirming this. So then we also usually describe it as noxious stimulus, so there's something that can be harmful, and only we can call it painful if the participant indicates that this is the case.
Which brain areas are usually involved when you experience pain?
There's quite a few. There's areas that are involved really on basically the sensation of the pain. So these are the somatosensory cortices. But there's also that are more involved in the evaluation or the motivational aspect, like that we want to avoid the pain, such as the insula and the cingulate cortex. So there's many different areas, also depending on the experiment that you're setting up with the situation that someone is in.
And you mentioned that you can't call it pain if you don't get verbal feedback, but when you would, or are you aware of experiments where you got the feedback of the participants, but also looked at what changes in the brain? So, like, are there changes as participants habituate to pain in how the brain responds?
Yeah, so in one of my studies, I looked at how the brain activity changes across several electrical stimuli. And then I saw that activity changes in some of the areas involved and that the activity decreases. And so this would kind of be another measure of habituation. But if you then want to link this to the ratings that participant gives, you can see that this is very difficult. So yeah, there's really different aspects. Of course, with the ratings, participants also have like this bias, or they incorporate a lot of aspects, the social situation where they're in. So it also makes sense that this is not one-on-one correlated to the brain activity. But this also makes it harder to get like, what does it mean that we have this decrease in brain activity, or what does these ratings mean?
Is there a tendency which starts to change first? So is it usually the brain activity that decreases first when you do a habituation experiment, or is it that the response tells, well, I feel less pain? Or is it not a rule and it's just, or it
I
seems to
think
be
that's
random?
it's a very interesting question, but also very difficult. Like kind of the what comes first. Do we become aware of our sensation and that is a result of the brain activity, or the other way around? Yeah, I wouldn't know the answer to that.
Okay.
And for sensitization, is it the same or is it different?
Yeah, it's interesting that for habituation there's been decades of research in all kind of topics, but for sensitization this is really less investigated, even though you would say that it's also very relevant since people report to have more pain. So also on the neural aspects, I wouldn't know of any research about this. And there's a lot about central sensitization that is often mentioned. I don't know if you've discussed this before, but this is that the nervous system becomes also more responsive. But this is really like a neurophysiological event, basically, and that is also, so this is not really something that you measure as as a behavioral response. So most of the research is looking into this, but I think it's important that we also look more at the behavior when people give increased responses of the pain, that we investigate this and relate that more to the neural aspects.
So overall, it's not fully clear yet how it works with sensitization.
Yeah, I think there's a lot of space for more research. And also, I think for habituation, the mechanism is still quite unclear.
Do you know in how far habituation and or sensitization relate to chronic pain?
So it's been hypothesized for quite a long time that these processes are related to chronic pain. And the idea was that people with chronic pain show less habituation. This could be like a result of the chronic pain, but also uh, more of a cause. But now there's more and more insights that it might not be so related to chronic pain. And there's more new evidence incoming that there's no differences in habituation responses between healthy participants and participants with chronic pain. And I think that researchers are always looking for these kind of biomarkers, so these indications or characteristics that can indicate whether someone has chronic pain or that this will develop, because of course prevention is better than curing. And I think this is one of the reasons why researchers looked into whether habituation can be such a characteristic of chronic pain. But it's really hard, I think, to have such a biomarker and such an indication.
I would just, how's it with sensitization? Like, is that related, or do we just not know yet?
Yeah, I think there's also not much known.
Okay.
It's been also like the other process I described, the central sensitization, that is more on the molecular level, has also been often seen as involved in chronic pain. But there's actually some study that came out, I think, a few weeks ago that was actually challenging this idea, while this was the case for decades. So this is still really ongoing, and yeah, difficult to say what actually is going on.
And how far is this new article challenging the previous view?
Yeah, so I think in general it's been assumed that central sensitization is playing a role in chronic pain or even causing it. And I think this new study really looked into whether the criteria are met. And then I actually found that there's no study that actually shows a causal role of central sensitization in chronic pain. So I think this is quite a big challenge and controversial. But let's see, maybe in a few months there's a new study that actually is showing it or measuring it in a different way. But I think it shows that there's a lot of unknown about general processes happening in chronic pain, and that we search for indications and mechanisms, but that it's such a complex process.
Are there, like, when people experience habituation or come to the lab, is it always the same for each participant or each person you're looking at, or are there differences between people?
Yeah, there's a lot of differences. When I first started investigating, I didn't expect to have these huge differences. And basically, there's not one person that shows the same response to the stimuli. And then, of course, you have the different patterns. So people that habituate to the stimulus or that sensitize. But people can also show like a stable response. And then there's, of course, very steep habituation. So someone that adapts very quickly or slower, or that first adapts to it, but then it increases a bit. So there's like unlimited amount of patterns or responses that people give, which is, I think, also interesting. If you talk to people what they experience in the lab, you get such diverse answers, which is really fascinating, I think, about how people experience pain. But this is also, I think, very important for research, that we do not only look at group level. Often you see that we average the results because we want to have a general conclusion, but then it's actually really important to look at these individual differences. And it also depends a bit on the study, I think, because I did a few studies, and then you kind of see that 1/3 of participants habituate and 1/3 sensitizes. But then also in one other study, this was a bit different. And then, of course, you don't know, is this just because of the variability of who participates, or is it some aspects of your study that results in more sensitization, for example?
How large testing groups usually, especially in these studies, you do? Because when you have such diverse response, how do you make sure that you can still find a pattern within your group?
Yeah, I think this is a good point, and something that, especially in some earlier studies, there were very small groups, like maybe only 10 participants. So in my studies, I try to have around 60 participants, so that you have like 20 per subgroup. But it's, of course, yeah, it's difficult what is enough, because you need to have also think about like the practical, that you need to get enough participants to go to the lab. But I think, yeah, it's definitely important to have enough participants so that you can look into this variability. And then also you can look a bit more into one of the interesting questions is what makes someone habituate and another person sensitize. So there's a lot of research going into this.
I was just about to ask, what are hypotheses? What causes which reaction? Like, is it how much pain you experienced, or is it how stressed you are in the situation? Like, or is it just arbitrary? And sometimes on one participant might react one way in one experiment and different in another one.
So the honest answer is that this is not known yet. There's a few factors that are investigated, like age and gender, like that people thought, but that doesn't seem to play a clear role. The role of expectations is quite big, as in with general pain research. And I think there's more research also into threat and these kind of, what you mean, like stress. And so the patterns can be a bit like stable if you test people multiple times, but it's not like 100%. There's also there a lot of variability.
So I feel like pain response is very individual. Like some people touch a mug
Yes.
and they are totally fine, and the next person tries to hold the mug and it's way too hot and they have to set it down.
Yes.
Do you think these kind of inter-individual differences already in the perception of pain can also play a role in habituation and sensitization?
Yes, I think that's definitely possible. I think also, for example, with the mug, it's also very basic influence of how your skin is like, what are the receptors in your skin like, and then also more the psychological, what do you expect from it. And this all together, I think, contributes, which makes it really hard to just find one factor that makes people habituate. But this is, something that is still ongoing, and I think there's more and more research, about this.
I do have a question where it's totally fine if you don't have an answer to, but it was just on my mind for quite some time now. On Instagram, or I sometimes see videos where people use menstrual pain simulators, and kind of women seem to not respond as sensitive as men. I just read through the comments, like, of course, a lot of people say, well, women tolerate pain much more, etc. But one comment that was that it's just a type of pain women are used to while men aren't. And I was just right now wondering if, at least for some women, this habituation part also plays into role into having less menstrual pain compared to others. And also when using these simulators, because women go through menstrual cycles about once a month. Not all, like menstruating people are going through menstrual cycle about once a month, not all, also depending on individual cycle length. So it's something they could get used to a certain degree. And is that also the reason why it's
I think if you describe it with like a simulator, that was definitely the first thing that also came to my mind. Like I think women are more used to this kind of pain. I think during one's own period, it's a bit more difficult because also it can fluctuate. But I think, in a way, you are used to this pain. I'm not sure. I'm often wondering like how much, since I research it so much and think about it. Like sometimes when I cut myself, I'm trying to influence my thoughts and see how effective this is. Like, okay, I'm now expecting the pain to go away. And I have the idea that it works, but I might be a bit biased as well. But yeah.
Also, just deep breathing and relaxing muscles actively, then at least to a certain degree supports. If it really does, we don't know, but at least it's a placebo.
Yeah.
With these menstrual pain simulators, I sometimes also wonder like how well they can transfer the illusion of menstrual pain. Because I mean, those are tiny electrodes which are stuck to your belly and induce some kind of pain, like definitely. But sometimes I wonder how accurate that is, and whether this accuracy applies for all menstruating people. But then again, pain is very individual and difficult, as we already learned. So this is something I always wonder when I see these kind of videos.
Same. And
I've never tried, so it would be interesting.
And I'm also thinking like people with uteri tend to have less muscle tissue at their uteri area, while people with no uteri tend to have more muscle tissue. And if you have electrodes, having more muscle tissue could also influence in how far or how much they are contracting. So I'm also just like, that was just why I'm always also super skeptical about those videos, but also kind of curious about them. Those things are guilty pleasures on Instagram.
Okay, you also do research with neurofeedback. Can you first explain a little bit what that actually means and how that could be done in general?
Yeah, so neurofeedback basically means that we get feedback from our brain signals. This can happen with different kind of brain measures. So if we use, for example, fMRI, where we measure the brain activity, you get if you're participated in such a study, you're lying in the scanner, and then you get feedback about your brain activity. And in this way, if you get feedback about your brain activity, you're potentially able to train that activity. If we see it in the context of pain, if you receive pain, then you have activity in these areas related to pain, brain areas. And then you can show, for example, to the participant how high the activity is in one such area. You can show that in different ways, but one common way is a sort of thermometer that indicates the level of the activity. And then if you then do like neurofeedback training, you can try to apply different strategies to decrease the activity and then decrease your pain. And this is then in a feedback loop to the computer, and that then again shows you the brain activity in that area and whether you were successful in trying to regulate this. So it's a kind of loop where you can try to train your brain activity. But you can also do this with other measures like EEG.
Okay, so if I were to join a neurofeedback experiment, and it would be a pain-related experiment, would I then basically lie in the scanner and be shown that I have a lot of activity, and I would try to somehow downregulate that?
Yeah, so it depends a bit on the topic and the task, but in terms of pain research, we want to achieve less pain, I would say. It's not sure if it's ethical to let the brain activity increase. But yes, then your brain activity is measured in the scanner depending on some sort of stimulus. So this can be a physical stimulus, but can also be an image related to pain. And then it's measured how high the brain activity is. And then you can try to regulate this. So you can like apply strategies such as distraction or thinking of happy things, these kind of things. And then it's calculated online, like, okay, how effective was this regulation? And then it's then shown again to the participant in an easy, interpretable way, like a thermometer. And this then goes on, and then you can try to train your activity.
And how do you determine, like, this is a lot of pain-related brain activity and this is not a lot of pain-related brain activity?
Yeah, that's a good question. Usually you do kind of a sort of baseline measure when there is not yet any training involved, so that you can see, okay, this is the response that someone has generally to a painful stimulus. And then you can compare it to that, whether there's a change in the brain activity.
Are there any, or are you aware of any findings on which which regulation methods seem to work for which type of pain? Or is there a tendency of which generally work well? So is it like distraction? Is it conscious breathing? Is it counting numbers? I don't know what else you could do.
Yeah, I think unfortunately the field isn't that far yet. So there haven't even been that many studies. So it's really a development, I think, of mostly the last decade. I think with fMRI, there's only about 5 studies. There's much more with EEG, since this is a bit cheaper and easier to apply. So I'm not sure if there's in that field a clearer image of like that the distraction is the best way, or actually like allowing it and immersing yourself into it. So yeah, I wouldn't know. It's like full of developments yet, like what is effective, and even like, is it even a method? So right now it's only in a research setting. There has been a few studies investigating it also for chronic pain, but this is still very early on, so it's not yet tested in a clinical setting.
I was just right now thinking about how sad that is, because there's so many people experiencing chronic pain or just also having surgery. And like my brain right now was just, my thoughts right now were just like, if there are ways to regulate that without painkillers, of course, painkillers are not wrong, but if there are ways to also regulate your system supported by painkillers or without painkillers.
Now, this would be the ideal situation, I
Yeah,
think,
of course.
when you can really train your own activity and influence it. That.
I was just thinking back, like I had a quite bad bouldering climbing injury some years ago, where I bruised my back in a way that I couldn't move for about 2.5 months.
Ooh.
Like it was really bad. It was really,
Yeah.
really bad. And I couldn't walk for about 1.5 months. So it was
Wow.
really, really bad. I told myself that it gets better when I relax and actively breathe into the muscle so that the muscle can relax. And I just told myself that that would help more than tension.
Yeah.
Because it made sense to me. But
yeah.
I'm just like, once again, startled by how little research or how little is known about what actually helps. Yeah. I think that's just my point.
Yeah, there's a lot of, I think, strategies to cope with pain. But this is also, I think, in part very individual. This is, I think, why there's not one strategy. And then it also depends on the type of pain I think you have and how long it is, whether there's a clear cause or not. And this is all just makes it very complex. But maybe in the future, neurofeedback will be the solution that you can just do at home, train your brain to become less sensitive. Yeah.
Get the little 4-electrode EEG kit, and then
Yeah, but then at some point it might even, like, if you think, if you take it too far, it can be even dangerous, right? Because the pain reaction, of course, is a healthy one, that we need to signal that there is something that can be harmful. So we don't want to get totally rid of this response. But in situations with chronic pain, of course, this might be really beneficial.
yeah, this would have been my next question.
Yeah.
Could there be like possible? Oh, sorry. Could there be possible side effects of using neurofeedback in a pain context?
I think, I mean, only if you would get like a reverse effect, when you would train your brain to become more sensitive to pain. I'm not sure if this is like something that can happen in practice, because then you would also notice, I think, this is happening. But there's, since this is also not very ethical, this also hasn't been studied that much. I think other than that, it's more like practically difficult. If you want to have long-term effects, you would have to go multiple times in the fMRI. So that's not really a side effect, but more something that it's, there should be a practical implementation, I think, a doing at home version.
So we're now waiting for the electrode headband to use at home to then
or
figure
like
out
the portable MRI mini scanner.
It's like, if anyone wants to develop that, feel free.
That also seems dangerous, because I feel like with an portable EEG headband, I feel like you can't do much harm, I know of. But I feel like with a fMRI scanner, like fMRIs are still pretty big magnets with pretty strong magnetic fields. I feel like with that you could make a lot of chaos.
It might not be the easy solution.
Was there anything left you would like to add, Maite? Because otherwise I think we could come to a close.
Yeah, I often had conversations with my dentist about pain, because of course this is a central topic when you go to your dentist. And one time he told me that he had a patient who needed to have removal of some teeth, and that he injected to have local anesthesia, but that it didn't work for the patient. So this was very strange. And then he didn't know what to do at first, but then he told the patient, like, why don't you go for a walk? And then the patient went for a walk and got distracted and maybe a bit more relaxed out of the situation. And then when the patient got back, the anesthesia was actually effective. And
Interesting.
I think this is really fascinating that, like, I feel like our mind really tricks us often. But then I think this story and also maybe like the neurofeedback shows that you can also try to trick your brain. So that, we shouldn't feel like, okay, everything that happens in our brain, we should just basically, like, we cannot do anything about it. But I think it's really powerful to think like, okay, we can also influence it or trick our brain. That's why I think education about pain can be really beneficial also in treatment, and just being aware of how these processes work and how susceptible they are to your thoughts and context.
I think like this already feels like a quite nice summary, but if someone has listened to that episode, what would be a take-home message for that person?
This is a difficult question. We talked about so many things. I think a summary is that there's a lot of research about pain, and that it's important to take into account all the factors, the psychological and the social factors, and that people can give very different responses to pain, so they can adapt to the pain, but they can also give increased responses to the pain. And there's a lot of individual variability in this case. And I think in the field of pain research, there's always people are always looking for new treatments and ways to minimize the pain.
And well, one last tricky question. What role would you say does cognition play in your research?
I think it's a very big role in pain research. I think every aspect of pain and the experience and the emotions we have is influenced by how we think about it and experience it. So I think this is really a big part. And I think also, interestingly enough, I think it's not often taught. I don't know what your experience is with it, but in my studies, it wasn't really taught. So I think it would be interesting to actually implement it in more studies, since it's such a universal and I think important subject.
Yeah, definitely. Okay, so with that being said, thank you so much for coming here, talking to us. It was a pleasure. It was a lot of information and really interesting. So thank you very much for your time.
Thanks.
Thank you.
You've listened to Kaleidoscience, Conversations on Cognitive Science, hosted by Elisa Palme, Sönke Lülf, and Sophie Kühne. Produced by Clara Kühne, Imogen Hüsing, Elisa Palme, Leslie Volk, Sönke Lülf, and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science. This podcast is not sponsored and does not give us any financial profit. If you wish to support us, the most effective way is to do so by leaving us an up to 5-star review on your chosen podcast platform and following us on Instagram. You can reach out to us via mail, comment on YouTube, or message us on Instagram. We are always happy to hear your feedback. Thank you again for listening to us and for your interest in science. If you have any questions regarding this episode or any of our other episodes, feel free to reach out. You can reach out to us via Instagram by sending us a direct message at kaleidoscience_pod or write us an email at kaleidopod@us.de. You can find both links to our Instagram and also the email address in our show notes. We do read all your comments and will also reply to you as soon as we can.